So suppose that we have these types of equations here. I know what's different to the ones um, that we did before compared to this one here. So the ones that we did before would have been like this. 2 cos squared x plus 3 cos x minus 1 is equal to 0. In those before, we would have had cosine and cosine alone, or sine and sine alone, or tan and tan alone. But in this case here, right, if you look at the first two, the third one we'll get to that eventually. The first two, we have cosine and we have sine in the same question. But it's really not too hard of a too big of a difference we have to make, right? So let's look at number one. All we have to do is we need to get the first one. We need to get the equation in terms of sine or cosine only. Now, there's not an easy way to change sine x into cosine of x, right? But there is a way that we can change cosine of x into sine x using one of the formulae, the identities that we did before. So if we know cos squared x plus sine squared x is equal to 1, and this will tell us we could change cos squared x. Cos squared x is equal to 1 minus sine squared x, right? So if that's the case, we could change where we have cos squared x, we could replace it with 1 minus sine squared x. So let's do that here. So this will give us 2 into 1 minus sine squared x minus 5 sine x minus 5 is equal to 0. Expand out our brackets here. So this will give us 2 minus 2 sine squared x minus 5 sine x minus 5 is equal to 0. Now, if we look at this here, right, let's just simplify it one more step again. Minus 2 sine squared x minus 5 sine x. No, don't forget this number, and this number here will give us minus 3 is equal to 0. Now, this looks more like one of the questions we had before because this is a quadratic trig with only sine terms in it. Yeah, this is sine to the power of 2 and x to the power of 2, sine x to the power of 1, and technically this is sine x to the power of 0. So now, just to make it easy, we could let some letter, not x, right? Because you use an x already in the question. So let p be equal to sine x. So this will give us minus 2p squared, because this is sine x all squared, minus 5p minus 3 is equal to 0. Now, at this point, you could use quadratic formula, you could use factorization, you could even use completing the square, right, to solve this equation. I am going to use quadratic formula. Not quadratic formula, sorry, factorization. Now, you could factorize here as well. Just like this, you know your full method. You give it two numbers, one multiplied, given us um, negative 2 by negative 3 and 6, and when added, given us negative 5. Yeah, you go through your list of numbers, right? And your list of numbers will give us negative 2 and negative 3 and so on. Now, there is an alternative way. You notice that A is negative. Now, I don't like factorizing when A is negative, right? So, what I do usually in this question, just to make it easy, is I multiply through by negative 1, both sides of the equation by negative 1. So I'll end up with positive 2p squared plus 5p plus 3 is equal to 0. And this is a much easier equation to factorize. Now, even factorization, there's many different ways to do it. There are many different ways to do it. So I like to use what I call a trial and error method, but you could use the techniques that you learned from before, right? The factorization, you could have learned it in the other videos. So with trial and error now, you notice that everything is positive in this case. So you know 2p plus something into p plus something will expand back out to give you this. 3 factors of 3. These two numbers have to multiply to give you 3. So it could be 1 and 3. We don't know. And let's test it. 1p plus 6p, because 3p by 2p is 6p, wouldn't give you 5p. So let's try the next way now. Let's try 3 and 1 here. 3p plus 1 by 2p is 2p is 5p. So you know that that's correct. All right, and that's the trial and error method, a nice, easy technique. All right, but again, you could use regular factorization. And we know at this point, when you have binomials multiplying, either the first term is equal to 0 or the second term is equal to 0. Now, at this point here, you know what you have to do. You have two different possible solutions for p. So you solve this one. This will give us p is equal to negative 3 over 2, or p is equal to negative 1. Now, a lot of people at this point here, they will stop and they'll say, oh, well, we solved the equation. But the question wasn't to solve for p. The question was to solve for x, right? So we have to replace p with what it is, which is sine x. So this will give us sine x is equal to negative 3 over 2, or sine x is equal to negative 1. Now, at this point here, what I like to do is to spread the answer, right? Spread it out on a page, right? Put one on one side, one a little bit further away to the right. The reason is that you have two different sets of working that you have to do here, right? Now, let me think about what this number is. This is telling us we need to find the angle whose sine is negative 1.5. But we know from the graph of sine, right? If we just do a quick sketch of the graph of sine, the highest value of sine is 1 and the lowest value of sine is negative 1, right? This is sine x here. But this number is negative 1.5 and that's underneath here. So if you notice the graph has no value, there's no value of x for when sine is negative 3 over 2. So what we say is that this values, right? So this, we can say this is out of range. Right, and the reason is the minimum value of sine x is negative 1. Right, I'm going to write that down. The minimum value of sine x is equal to negative 1. Right, so you can't get an answer from this one here. Now, this here, you have two different ways to do it. All right, I will do it with the longer way because I know you're just getting familiar with trigs. Um, but I will show you the shorter way in a short while. All right, so we do the same thing as we doing before, right? We say that since sine x is negative, right? And we look for our quadrants A, S, T, C, first, second, third, fourth. All are positive in the first, sine alone is positive in the second, tan alone is positive in the third, and cosine alone is positive in the fourth. So since sine is negative, you look for where sine is not positive, so that will be in the third and fourth quadrants. Right? So what we see here is that x is in the third, or well, you can say and because it's two solutions, third and fourth quadrants. Yeah. So x is in the third and fourth quadrants. We know in which quadrants it lies. The next thing we have to find out is what we call the primary value of x, right? Which we call alpha, and that will give us. We know that that is the inverse of the positive value of the key here, and that'll give us sine inverse of 1. Now you can work this out in a calculator, right? But at this point, sine inverse of 1 is supposed to be um, fairly easy for you to know. You can always recall from the graph, but this here will give us 90 degrees. Now remember, at the beginning of the question, you were supposed to look at the range that we use. The range in this case is in degrees. So this is why our angles are to be in degrees here. Yeah. Now, this is the third quadrant. So I like to call it theta 3, which is your third quadrant angle is, we know the formula to work out the quadrants. The first quadrant is alpha. Second is 180 minus alpha. Third is 180 plus alpha. And the fourth is 360 minus alpha. We're looking for the third and fourth quadrant. So the third quadrant is 180 plus alpha, which will give us 180 plus 90 degrees, which is 270 degrees. So that's the third quadrant value. That's for our fourth quadrant value. That's 360 degrees minus alpha, as this one here, which will be 360 minus 90 degrees, which also gives us 270 degrees. So therefore, what we end up with is that theta is equal to 270 degrees only. And that's the answer there. right? So this one is solved just like a regular quadratic trig with the addition of this here, right? Once you have cosine and sine in the question, you change the squared one into the not squared one. If this is cos squared, you change cos squared to 1 minus sine squared. So if this is sine squared, well, you will see it in the next question here that we're going to do. Right, so let's look at number 2 now. Right, so number 2 is this. Whoops, a little bit too much here, right? And feel free to pause the video. Remember, this is a video, so you don't have to watch the whole thing at once. You can pause the video, go through, make sure that you understand, and that's why you have to use the videos to your advantage. All right, so number 2 is this. All right, so how do we solve this here? Now, first of all, we know that this looks quadratic-ish, right? Because we see in sine square and we see in cos x, and we know that we can change this here. All right, but also take note that this is in radians. So once you see a question has sine, cosine, or tan in it, right? Or if you're doing, more advanced maths, sec, cosec, and cot, and but once a question has that in it, you have to change your calculator accordingly. This range is given in radians, so your calculator has to be in radians. So we know one of the first things we have to do is make one of the sides 0, because to solve a quadratic, either the left or right hand side must be 0. So we transpose, we subtract 1 and cos theta from both sides. So you get 2 sine squared theta minus cos theta minus 1 is equal to 0. Yeah. Now, again, just like we did before, we know that we can't solve this as is. So what we do, we change the sine squared into 1 minus cos squared. So since sine squared theta plus cos squared theta is equal to 1, this will give us that sine squared theta is equal to 1 minus cos squared theta. So this will give us 2 into 1 minus cos squared theta minus cos theta minus 1 is equal to 0. And we do the same thing as before. So this will give us 2 minus 2 cos squared theta minus cos theta minus 1 is 0. Simplifying, this will give us negative 2 cos squared theta minus cos theta, and 2 minus 1 is plus 1 is equal to 0. Now, this is a quadratic only in terms of cosine. So you could let some letter, any letter, I'll go back with P again, let P be equal to cos theta. So this will give us minus 2p squared minus p plus 1 is equal to 0. Right, and now at this point here, you could go ahead and solve how you want. Now again, my a is negative. I don't like my a to be negative, so I multiply throughout by -1. You can only do this if this side is a number. If it's like y and thing, don't do that, right? Obviously, to solve a quadratic, this side must be 0. So when it's equal to 0, multiply through by -1 if you want. So this gives me 2p squared plus p minus 1 is 0. Right? Again, there are multiple ways to solve this quadratic formula, factorization, um, different ways of factorization as well. Right? So I will go again with the trial and error. So this is 2p and p. Now the problem with this one here now is that one of these numbers is negative, right? So since this number is negative, it means that these two numbers have to multiply to give you a negative. So one must be positive, one must be negative. The only thing that can multiply to give you 1 is 1. Now you test to see if your sign's in the correct place. This is 1p minus 2p is minus p, but this is plus p. So you switch your signs now. Minus 1p plus 2p is 1p, and that's correct. Right? If you're unsure about that technique, remember I have other videos showing how to do that. And again, you could use your regular factorization technique or quadratic formula. So this will give us 2p minus 1 is 0, or p plus 1 is equal to 0. Right now, this will give us, when we solve for this here, you subtract 1 from both sides and then you divide both sides by 2, which will give us a half, or subtract 1, so you add 1 to both sides and then divide by 2, or you subtract 1 from both sides and give us p is negative 1. So are we done here? Yeah, think about it. And the answer is no. We are not done because the question wants us to solve for theta, not for p. So you have to change back this now, this p value, into cosine theta. So this will give us that cosine theta is equal to half, or cosine theta is equal to negative 1. Yeah. And now remember what I taught you as well before. When you reach to this stage, you break them up, well, spread them a little bit further apart as far as you could on the paper, right? Because you want to be able to have enough space to work for both of these questions. Yeah. And now this is the same thing now, right? Cosine theta is positive. So we write, since cosine theta is positive, this symbol means positive, right? What this tells us, if we use the, I'm writing on this side here, ASTC. Where is cosine positive? It is positive in the first quadrant and the fourth quadrant. So this implies that theta is in the first and fourth quadrants. All right, so now we know theta is in the first and fourth quadrants. We have to find the primary value of the angle. Primary value alpha. And we know that that's arc cos, or cos inverse of the positive value here, which is positive 1 and positive a half. That's fine. Right now, remember again that you are dealing with radians. So you're supposed to learn off the, well, not learn off, you're supposed to remember trig, um, the trig, well, the triangle, sorry, that I taught you before with 60, 30, and 45 degrees. If you remember those, this will help you out a lot. But if not, put it in a calculator, but cos inverse of a half. Remember, we deal with radians, which means that it have a chance that you're going to get a pi value, right? So when you look for cos inverse of a half, right, you will see that that answer is actually a third pi, or pi on 3 radians, right? Now, if you put this in decimals, you will get 1.047, right? To four significant figures. Um, but my advice is try to keep it as exact as possible. So make sure that you know these triangles here, right? Where you have 60 degrees, 30 degrees. This is 2, 1, and root 3. And you know how to work with these triangles here, right? So pi on 3 radians. Now that we have this as pi on 3 radians, we can now work out our quadrants. So our first quadrant value, the formula fit, right? I'll write the formula over here. Remember, first quadrant is always alpha, second quadrant is 180 minus alpha. But in radians, 180 is pi. Similarly, this is 180 plus alpha, and this is 360, which is 2 pi minus alpha. So we're looking for our first quadrant value, which is just your primary angle, which is pi on 3 radians. Now remember, radians also have another symbol like this up. This means radians. You can use that if you want, right? But this is what CXE usually accepts. And theta 4, our fourth quadrant value, is 2 pi minus alpha. Right, so this will give us 2 pi minus pi on 3. Now 2 pi is the same as 6 pi on 3. So 6 pi on 3 minus 1 pi on 3 is 5 pi on 3 radians. Now again, we're not done yet. And the reason why we're not finished here as yet is because we still have this whole side to go. We have to see if it working, which it will, right? And then we'll this out. Now again, I'm going to do this the longer way. I will show you later down. There's a shorter way to do when you have one of the trigs is equal to 1 minus 1 and 0. But for now, let's just go with this. So we say that since cos theta is negative, This implies that if cos theta is negative, where does this go now? Cos theta is negative where it is not positive. So that's in the second and third quadrants. So this implies that theta is in the second and third quadrants. All right, so we again have to find a primary value because we have a new value, a new sine value to deal with here, a new cosine value, sorry, to deal with, which is our cos of the positive of this number, right? Our cos of 1. And but I mean, this is again something that you will learn from knowing the graphs. Our cos of 1 is 0 radians, right? So this is your primary value. So therefore, theta 2, second quadrant value is this one here, pi minus alpha, which is pi minus 0, which is just pi radians. And theta 3 is pi plus alpha, which is again pi plus 0, which will give us pi radians. Yeah, and now we finish here now, but when you finish with this, you always conclude with all the possible values. Therefore, theta is equal to, you could put it in ascending order. If you don't, I mean, I don't foresee you losing any marks, but I mean, put it in ascending order now. So this is 1/3 pi. So you put that here, pi on 3 radians. This is 1 pi radians, right? And this one here is 1 and 2/3. So you can just put it as 5 pi on 3 radians. And that's the possible answers there for this case. So feel free to pause the video at any point, go through the video. If you have any questions, you can always message and ask, right? But yeah, but as these two questions here. All right, so the third question, I will come back to that one. Right, I'll probably do another video with this because this video gets a little bit long, right? But basically for this one, you notice that this is in the denominator. If this is in the denominator, what we have to do is bring it to the numerator. How we do that through cross multiplication, right? And then you expand out the brackets and so on. But we'll do that in another video, right? But this video is just for these first two here, right? Because those are the more important ones. All right, so I will see you in the next video.